So on page 43, on the right-hand side, we're going to do the anchor chart, and on the left-hand side, you should have your flaps that you're going to practice this underneath. So we have the standard algorithm. And our problem is going to be 358 multiplied by 74. So this is how back in the day us old folks used to do math. We didn't really know why it worked, but hopefully because we've done the past three, you should know what is happening. Okay, because we talk about place value and we talk about digits all the time. So when we do this, you should understand, which is why we do all four of them, is so that you know what you're doing. Because when we did it, we just knew that, oh, you do this and that's a placeholder and you do that and you do that. Cool, we might have gotten the answer right, but we have no idea why we did it and what it all meant. We just were told that that's what we did. You, on the other hand, have all this background knowledge, your schema, and so that's really, really going to help you with this, okay? So, we have our first step, which is we multiply the multiplicand by the ones place in the multiplier. Okay, so we multiply the multiplicand by the ones place in the multiplier. Well, when we do this problem, we set it up just like we did partial products. So we line them up just like that. And we multiply the ones place by the 8 and then by the 5 and then by the 3. So we're taking the 4 and we're multiplying it by 8. Then we're going to multiply it by 50, really, and then we're going to multiply it by 300. Okay? So we go 8 times 4 is 32. We put the 2 down and we carry the 3 because it's a 10 over here. And then we go 4 times 5. But what really happens is we're multiplying 4 times 50 because that is 58. So let's pay attention. We go 4 times 5 is 20, but really it's what? 200 plus 3 because that's 10 from 32. So it's really 200 plus 3 or 30, which is 230. But we don't talk about that. But that's really what's happening, okay? So we multiplied 4 times 8 and we got 32. Well, we carried our 10 and then we multiplied 4 times 5, but the 5 is really a 50. So we get 20, but it's really 200 plus 3. So we have 230. But when we do it quickly, all we think is we have 23. So we drop the 3 down and we carry the 2, which is really 200 because 50 times 4 is 200. See how, see? Okay, then we go 4 times 3 is what? 12, but it's really 4 times 300. What? So 4 times 3 is 12, plus 2 is 14. So when we multiplied 4 times 3 is really 300. We got 1,200 plus 200 equals 1,400. See that? Okay? Then we are going to step number 2. We're going to put a 0 as a placeholder. Because you are multiplying by the tens place, or possibly the hundreds place. Oh, sorry, no, this is tens place. If we had 3-digit, the hundreds place, or possibly the thousands place, okay, and so on. So that's the reason why we put a placeholder. Your parents and I would say we put a placeholder. The reason why is because when we start multiplying by the 7, it's not really a 7. What is the value of it? It's a 70. Do you see why it's so important for us to understand the value of the numbers in order to do multiplication? Okay? So, we put a 0. We're going to put a 0 because when we start multiplying by 7, it's really 70. And so we have to have a 0 because we would multiply 0 times 8, 0 times 5, and 0 times 3, which equals 0. Yes, so that's what we are doing when we're putting 0. So if we had a 1 here, once we got through the 7, and we got to the 1 or the 5 or the whatever number here, we would put 2 zeros because we're not multiplying by 1, we're not multiplying by 10, we're really multiplying by 100 place. The next step is, then you multiply the multiplicand by the tens place, so we'll multiply by 70, or if it had 100, we would multiply that after, and so on, okay? So you multiply, after you do the ones place, you put a placeholder for whatever place this number is in, you multiply it, then you put a placeholder for whatever number this is in, and you multiply it. So we multiply the multiplicand by tens, hundreds, in the what? What is this number? The multiplier. Okay, so we put our placeholder. Now we are going to multiply by 7. First, we have to cross these off so we don't get confused with our next carrying bunch. So we're going to go 7 times 8, which is what? 56. But really this is 70. So it's 560. So we put the 6 down here because it's 60, and we carry the 5. Then we go 7 times 5 is 35, but really it's 70 times 50, which is 3,000, what? 500. And I know you're like, well, Miss Rushton, this is still the tens place. It is the tens place, but we would really have a 0. So we would be pushed down anyway. So we go 7 times 5 is 35 plus 5 is 40. So we bring the 0 down and we carry the 4. And we go 7 times 3, which is 70 times 300, really, is 21 or 21,000 plus 4 is 25. Okay? So we went 7 times 8, which is 56, carried the 5. We went 7 times 5, which is 35 plus 5, 40. We drop down the 0, we carry the 4. We go 7 times 3 is 21, plus 4 is 25. Now, since that's all the digits we have in the multiplier, what are we going to do with these products that we have? We're going to add them up, which is the hardest part. And we're still doing our extra math to help us. So we're going to add these up. And if you notice, we did such a beautiful job. They're in place value order, so we don't even have to like rewrite them or try to figure that part out. So we go 2 plus 0 is 2. Then we go 3 plus 6 is 9. 4 plus 0 is 4. 5 plus 1 is 6. 2 plus nothing is 2. So we have 26,492. And remember, if we want to check it, if we want to see if it's reasonable, not necessarily check it because we do the check, we would round this and we would round this and multiply them. So let's round up. We're going to go, this would turn to 400 and this would turn to 70 because this is 0 through 4 stays the same. So 70 times 4 is what? It's 28, but we really have 400 times 70, which is going to be 28,000. This is close to 28,000. So is our answer reasonable? Yes. Okay, so if you multiply a 3-digit by a 2-digit and you don't get a 5-digit number, something is going wrong. Okay, so you always have to be thinking. You don't just do the math and go blah, whatever. You have to be thinking, is my answer reasonable? So now that we have this, what should we do? We should probably check it with our friend Abe Lincoln. Okay. On the top, we have the sum of our multiplier digits. So we're going to add 3 plus 5 plus 8. We're going to add 3 plus 5, which is 8. And then we're going to add 8 plus 8, which is 16. Remember, making like things we know how to work with. Well, we can't have 16, so we go 1 plus 6 is 7. Then we find our multiplier digits. And we go 7 plus 4 is 11. Can we have 11? No. So we go 1 plus 1 is 2. Then we multiply 7 times 2, which is 14. Can we have 14? No. So we go 1 plus 4, which is 5. But we can have 5. Now we're going to add our product. So we are going to go 6 plus 4 is 10, and we're going to hold it. And then we're going to go 2 plus 2 is 4, plus 9 is 13, plus 10 is, 13 plus 10 is 23. But can I have 23? No. So I'm going to go 2 plus 3 is 5. These two match, which means my answer is most likely correct. Okay? So we are going to I'm going to give you some problems to practice, and then when we come back, we're going to practice as a whole group. Okay?